Nice having you once again, my great scholars. Jam pass question 2001, number 27. A working electric motor takes a current of 1.5 amps or ampere when the potential difference across it is 250 volts. If its efficiency is 80%, the power output is. Our question is centered on efficiency. Efficiency of an electric motor or efficiency of a machine. Okay, let's observe. Efficiency can be in the aspect of work input and work output, or in the aspect of power input and power output. Efficiency. Okay, under work, efficiency is given as efficiency is equal to the work output must be your numerator. Please, never you do this mistake of keeping the work input as the numerator. The input is always the determinant. It stays under. The input is your denominator, while the output is your numerator. Okay, so work outputs all over work inputs times 100%. These are efficiency. And recall, efficiency of a machine is less than 100%. It's less than 100. That makes it a real machine. When it becomes 100% exact, that becomes an ideal machine. Machine that exists in the world of ideas. Okay. In the same way, efficiency can also be in a new pattern. In the pattern of power. Efficiency can also be power outputs all over power inputs times 100 all over 1 or 100%. So be rest assured that efficiency can come in the aspect of work done or in the aspect of power, but the pattern is maintained. The output is always the numerator, while the input is always the what? Denominator. That is when you will get something less than 1. And when you times 1 by 100, that gives 100%. So that's when you get something less than 100%. The output is always smaller than the input. You cannot bring out more than you've taken. You can't bring out more than you've taken. Okay, what do I mean by that? Whatever energy you put in a machine, you can never get that energy completely out from that machine. That machine must make some useful wastes. So the output is always less than the inputs. You take 10 to bring out 9, 8, or less. You can never take in 10 to bring out 10. It's impossible. It's against the law of conservation of energy. In converting energy from one form to another form, some amount of energy must be wasted because it's used for waste. So that's why the formula is that way. So let's push ahead. Okay. Observe. From the question, we were given currents. Let's get our parameters out. Current is 1.5 ampere. We were given potential difference, PD, 250 volts. We were given efficiency, 80%. Then the question is demanding for power outputs. Power outputs. Okay. So this requires the idea of electricity to do it. Electrical power is given us. Power in the world of electricity is given as IV. This electrical power, IV. Then if the question is demanding for power outputs, that means the current we have here and the voltage we have here will all represent power inputs. The electric motor absorbed current of 1.5 ampere, voltage of 250 volts. So when we multiply our current and the voltage of the PD, we'll be getting our power inputs. Okay. Then let's solve. Okay, using this formula, we'll be having efficiency has been given 80 equals power output is what we're looking for. Power inputs, let's solve for power inputs. Power input will be the current, 1.5 times the voltage, 250. We'll be having 375 watts. So these are power inputs. Then we'll come back. The power input will be put in 375 times, we'll continue with the formula 100 all over 1. Okay, at this point, let's multiply to make it simple. Let's call it just P. 100P over 375. This over 1, cross and multiply. Okay, so 100P times 1 is 100P. Equals 80 times 375, giving us 30,000. 30,000. Then making P the subjects. P is equal to 30,000 divided by 100. 2 zeros to cancel 2 0. Therefore, our power output is equal to 300 watts. 300 watts. Okay. Then observing from the options, we can see that the best option there is option A. Option A that indicates 300 watts. Okay, let me guide you on the basis of this formula. How this formula came about. Recall in mechanics, power is work done over time. Recall, work done is force times distance all over time. Continue. Then let's go electric. In the electrical world, power becomes work done in the electrical world all over time. Then the force in the electrical world is voltage. What covers distance in the electrical world is charge. Everything over time. Time is the same everywhere. Then observe. Q over T. Q over T is definition for something. And what could that be? Current. Current is the flow of charges with respect to what? Time. Therefore, P is equal to VI or IV. This is how the formula was derived. Okay, this to prove to you that for you to do well in physics, you must have mastery of physics formulas manipulation. Thank you. Stay tuned as we push ahead.